Bismillah ar-Rahman ar-Rahim. Random variable x has probability density function given below. Fx of x is equal to cx e raised to the power minus x over 2 when x is greater than or equal to 0, and this is 0 otherwise. Sketch the PDF and find the following. Part A, the constant c. Part B, the CDF fx of x. Part C, uh, probability that x is greater than or equal to 0, less than or equal to 4. Part D, probability that x is greater than or equal to minus 2 and less than or equal to 2. So let's begin with the solution. Before sketching the CDF, let's find the constant c so that we know the PDF and then we can sketch the PDF. So part A, the constant c. To find the constant c, we use this property of the PDF, that the area under the curve of the complete PDF is equal to 1. So the integral, for example, from minus infinity to plus infinity of the PDF is equal to 1. So in this case, we see that it is only x is greater than or equal to 0. So we can divide this integral from minus infinity to 0 and then 0 to plus infinity into two parts. So for example, we can say from minus infinity to 0. So fx of x dx and plus 0 to plus infinity fx of x dx is equal to 1. But this part from minus infinity to 0, but because this is negative and this is 0, the PDF is 0 for the negative values, because it has this value only for when the x is positive. For all other values, this is 0. So this is 0, right? So if, in effect, this we can write as 0 to infinity fx of x dx is equal to 1, and this part is uh, 0. So only this part is equal to, so we can write that fx of x dx is equal to 1. So now putting the value of fx of x for these limits, so we can write cx e raised to power minus x over 2 dx, when the limits are 0 to infinity, it is equal to 1. So we can integrate this uh, by parts. So integrating by parts. For example, we know that uh, integral of type u dv with limits a to b can be written as uv with limits a to b minus limits a to b v du, right? So here we can assume this to be u and this to be dv. So u dv, so this is u, this is dv. So u is equal to cx, right? And dv is equal to e raised power minus x over 2 dx. So if u is equal to cx, then we can write du is equal to c dx. And similarly, if dv is equal to e raised power minus x over 2 dx, then v is equal to the integral of e raised power minus x over 2 dx, right? And this should be equal to 1 over minus 1 over 2, that is minus 2 e raised power minus x over 2. So we have all these values u and v du and dv. We can put in these values here to evaluate the required integral, this one. So this comes out to be, uh, we can write it like this: cx e is power minus x over 2 dx 0 to infinity is equal to, now u is cx, and v is equal to minus 2 e raised power minus x over 2, right? And the limits are 0 to infinity. 0 to infinity, this is the limit here. And then minus v du. So v is again uh, minus 2 e raised power minus x over 2, and du is c dx, right? And this is 0 to infinity, and this should be equal to 1. So let us write it in a more compact form. So it will be like, for example, minus 2 uh, c x e raised power minus x over 2, limits 0 to infinity, and then this minus minus will uh, come out to be plus, and this is constant 2 and this is constant c. We can combine them like here, 2c, right? And the limit is 0 to infinity e raised power minus x over 2 dx, and that should be equal to 1, right? So we need to evaluate this limit. So when we put in infinity here, so this term is infinite, right? And but the lower limit, when we put in 0, this turns out to be 0. However, we need to evaluate this limit when this is infinity. The upper limit is infinity. We need to evaluate it for this. So this is indeterminate at this upper limit. So for this, we use the L'Hopital rule. Uh, L'Hopital rule. So according to this rule, limit when x tends to, for example, a constant a, for this ratio f of x over g of x is equal to the limit that when x tends to a, f dash of x, the first derivative of fx, and g dash of x, the first derivative. So we can differentiate the numerator and the denominator, and then we can put in the limit and evaluate it. So here, this can in fact be written in the form of this kind of ratio. This minus 2cx is f of x, and this e raised power minus x over 2 is equal, actually 1 over e raised power x over 2. So this will be our g of x. So using this L'Hopital rule, we can evaluate the limits for this function here. So let's do that. So this was uh, minus 2c. This is minus 2c e raised power minus x over 2, e raised to the power minus x over 2, right? And we need to find the value at infinity, limit when x tends to infinity, right? And that, according, that can be written as, first write it, let's write it in a ratio, in the form of ratio x tends to infinity. So this is minus 2c over e raised power x over 2, right? So here we also have x, sorry, so 2cx minus 2cx, right? So this is 2cx and x here. And now using this rule, we can differentiate the numerator and the denominator, and this should be equal to the previous. So so this is equal to then limit that x tends to infinity minus 2c x e to the power minus x over 2 is equal to limit that x tends to infinity. So we can differentiate minus 2c dx by dx divided by d by dx e to the power x over 2, right? So this is equal to minus 2c, right? Limit that x tends to infinity. So this is minus 2c divided by, so this will be 1 over 2, 1 over 2 e raised power x over 2, x over 2, right? So, so this is now a constant, right? This is not affected by this when x tends to infinity, but this denominator when x approaches infinity, this is this term is infinite. So, as a result, our this whole fraction comes out to be zero when x tends to be x tends to infinity. So we can now substitute the limits here. We know that this term, when x approaches infinity, is 0, and the lower limit is also 0. This whole term vanishes. So this comes out to be 0. So it means that we're left with only this term, and which should be equal to 1. So this means 0 plus this term should be equal to 1. So we can substitute. Uh, so we can write it equation 1, right? Let's write it equation 1. And from 1, we can substitute this term to be 0 plus 2c 0 to infinity e is power minus x over 2 dx is equal to 1, right? So let's now evaluate this integral. So this is 2c, right? And then this is minus 2 e to the power. So this is minus 2 e to the power minus x over 2, right? And the limits are 0 to infinity, and this should be equal to 1. So let's now put in the limits here. So this is actually minus, we can write it minus 4c. And then we can put in the value. So this is 1 over e raised power x2 when x tends to infinity, this is 0. And then minus, we put in the value of 0 here, e raised power 0. This should be 1. And this whole is 1. So minus 4c and e raised power 0 is 1. So this is 0 minus 1 is minus 1 is equal to 1. So that means 4c is equal to 1. So c is equal to 1 over 4. So we have evaluated, found out the value of the constant c here. So we can write the PDF by substituting c for its value. So fx of x is equal to this is 1 over 4 x e raised power minus x over 2 when x is greater than or equal to 0, and this is 0 otherwise. So this is the complete CDF of the function. So we can plot the value, for example, for the CDF. We can now sketch it. So this is x, and this is fx of x. So at 0, this is 0, right? And this it does not have and it is 0 at the negative values, right? It is 0 here, and it is 0 at 0. And for example, at 1, this is e raised power minus 1 over 2. And at, for example, 4, it is, for example, 4 in over 4 into e raised power minus 4 over 2. So with the large values, this term becomes quite small. So to certain values it increases, but then it becomes a small, because this exponent is negative. So in a way, we can see that it can be drawn something like this. This is only an approximation, right? If we need an exact plot, we can just make a table, put in the different values of x, and then find out the values of fx of x, and then we can plot it, right? So this is an approximate plot of the CDF. So this was our first part that we needed to find. Now the part B, the CDF fx of x. Part B, uh, the CDF fx of x, right? So the CDF fx of x from a PDF can be found, uh, for example, using this formula from minus infinity to x. This is, note that this is the variable x here, and we are integrating basically the PDF. Uh, so let's use a dummy variable here, not x, because we need to get a function in terms of x. So fx, for example, we can put in a dummy variable y, and we can write dy here. So when we substitute the limit, so this dummy variable will disappear. So this is how we find the CDF from, if we know the PDF. So the PDF is known here, and we can find the CDF by integrating this PDF. And if we want to find the PDF given the CDF, we need to differentiate the CDF to find the PDF. So in our given case, fx of x is equal to, so we know that it is 0 for negative values. So the integral from minus infinity to 0 is does not exist, and it's 0. So in fact it will be from 0 to x, right? 0 to x, and the value of the CDF, we know that is, if we have already found the value, 1 over 4 x e raised power minus x over 2. But we will write in terms of the dummy variable here. So we will replace x with y, right? So this will be 1 over 4y, 1 over 4y, and e raised power minus y over 2 and dy. So y is a dummy variable. What we are using y as a dummy variable here. So now this is the same kind of integral that we already evaluated uh, here, right? Yes, here, to find the value of the constant c. Now the constant c is known, but we are now integrating it to find the CDF. So again, using the same technique that we used earlier, we can use integration by parts to find the value. So integrating by parts. So we know that a b limits u dv is equal to uv for limits a to b minus v du with limits a to b. So here we can treat this as u, and this can be treated as dv. So u is equal to 1 over 4y, so that du is equal to 1 over 4 dy, right? Similarly, dv is equal to e raised power minus y over 2 dy, and v can be found using the integral of e raised power minus y over 2 dy. So here v is equal to um, minus 2 e raised power minus y over 2, right? So we can put in the values of u and v and du and dv here to evaluate the integral. So fx of x is equal to, so uv. So u is 1 over 4y, and v is minus 2 e is power minus y over 2, right? And the limits are 0 to x, 0 to x, and then minus v du. So uh, v is minus 2 e is power minus y over 2, and du is 1 over 4 dy, right? So fx of x is equal to, so this will be minus 2 over 4 gives us uh, minus 1 over 2 y e is power minus y over 2, and the limit is from 0 to x, and this is again minus 2 over 4 is minus 1 over 2, and this minus gives us plus, so plus 1 over 2 e raised power minus y over 2 dy, and limits are 0 to x. So again, to evaluate this integral, uh, now this is not infinity here, so we do not need to use the L'Hopital rule anymore. So we can put in the value of x. Uh, so this is equal to uh, minus 1 over 2 is the say constant, we take it out. So this is x e raised power minus x over 2, right? And then minus, uh, this is zeros, right? So we substitute 0 here, so this is 0, right? And when we evaluate this, this part, this integral, so this is plus 1 over 2, and this e raised power minus y over 2 is again minus 2, 1 over 2 into minus 2 e raised power minus y over 2, right? And the limits are again 0 to x. So fx of x is equal to, this is minus 1 over 2 x e raised power minus x over 2, right? And this is this cancels out with this, so this is minus, and we can substitute the value e raised power minus x over 2 and minus e raised to the power 0, so this is 1, right? So fx of x is minus 1 over 2 x e raised power minus x over 2, so this is minus e raised power minus x over 2, and this is plus 1. So we can take this common, e raised power minus x over 2. So actually, in fact, minus e raised power minus x over 2. So fx of x is, so this is 1, and we can take minus e raised power minus x over 2 as common from these two terms. So we're left with this is 1 over 2x, right? So 1 over 2x or x over 2 and plus 1 here. So so this gives us the CDF, right? So we can write the CDF like this: fx of x is equal to 1 minus x over 2 plus 1 e raised power minus x over 2 when x is greater than equal to 0, right? Greater than or equal to 0. When x is greater than or equal to 0 and this is 0 otherwise. So this gives us the CDF, and we're done with the second part of the given problem. So we're now to find this probability that x is greater than or equal to 0 and less than or equal to 4. We can use both the PDF and the CDF to find the this probability over this interval. However, if we use the PDF, we have to evaluate an integral. And if we use the CDF, we just need to substitute the values of these endpoints in the CDF, and we can find out the this probability. So let's proceed with part C. Part C. Part C is about probability. Probability that x is greater than or equal to 0 and less than or equal to 4, right? So using the PDF, it is it can be found probability that x is greater than or equal to 0, less than or equal to 4 is given by this integral from limit 0 to 4 and fx of x dx. We can put in the value of this. We can put in the CDF that we have already determined here, and this CDF, and then if we can evaluate the integral to find this probability. So probability that x is greater than or equal to 0, less than or equal to 4 is given by this integral 0 to 4 and this 1 over 4 x e raised power minus x over 2 dx. So probability that x is greater than or equal to 0, less than or equal to 4 is given by 1 over 4, and then we need to proceed by parts. 0 to 4 x e raised power minus x over 2 dx to evaluate this integral, and this will again lead to a lengthy computation. So instead we can use CDF, which will be very easy to substitute just the values of the endpoint in the CDF and find out this probability. So you can evaluate this integral, in fact, to find the probability, but as said, this will result in a lengthy computation. So let's use the CDF. So probability that x is greater than or equal to 0, less than or equal to 4 is given by fx at 4, the value of the CDF at 4 minus the value of the CDF at 0. So we can just put in the value in the CDF that we have already found. So the CDF we have found here, right? So probability that x is greater than or equal to 0, less than or equal to 4 is given by, let's put in x is equal to 4 here. Substitute x is equal to 4 here. So this will be 1 minus 4 over 2, right? And plus 1 e raised power minus 4 over 2. And then we put in the value of subtract when the value of the CDF at 0. So we now put 1 minus, so this is 0 over to 0, and this reduces to 1, leaves only 1 here, and then e raised to the power 0 over 2 is again 0, right? So this involves only simple arithmetic instead of previous calculations which involved evaluation of integral. So x greater than or equal to 0, less than or equal to 4 is equal to, so this is 1 minus, this is 4 over 2 is 2, 2 plus 1 is 3. So this is 1 minus 3 e raised power 4 over 2 is minus 2, right? And this is 1 minus 1, right? And e raised power 0 is also 1. So this leaves us with 1 minus 1 is 0. So this term vanishes and this is 0. So this disappears. So basically, the probability is given by this simple expression. We can rewrite it like this: x greater than or equal to 0, less than or equal to 4 is equal to 1 minus 3 e raised power 2. So this is the part 1, sorry, part C. And now to the part D. Uh, in part D, we are required to find probability that x is greater than or equal to minus 2, probability that x is greater than or equal to minus 2 and less than or equal to 2. So again, we can use either the PDF or the CDF to evaluate this, to find this probability. However, using the PDF, we will need to evaluate an integral, which may be a lengthy process. We can just use the CDF to find the probability. So from the CDF, so this is fx at 2, then minus fx at minus 2. So one thing that we know is that this CDF exists only for when x is greater than or equal to 0. For negative values of x, this is 0 because it is said this is 0 otherwise. So fx at minus 2 here is a 0, but we need to find out the value of fx at 2, for which we can do by substituting 2 here in this CDF that we have already determined. So this is equal to so this value here 1 minus, so this is x is 2 over 2, and this is plus 1 e raised power minus 2 over 2, right? We have substituted 2 here, right? And then this is 0 because the CDF is 0 for all negative values. So this gives us 1 minus, so this is 2 e raised power minus 1, and this is 0, we leave it out. So this is equal to 1 minus 2 over e. So the probability that x is greater than or equal to minus 2, less than or equal to 2 is equal to 1 minus 2 over e, right? So this completes the solution to the given problem.